The last part of coordination. So we are continuing with sense organs and we're continuing with the eye. When we get done, we're going to take a look at the ear, which is a bit short. So we're going to look at defects of the eye. So there are basically about three types of defects of the eye. The first is short sight, which is also called myopia. The second is long sight, which is called hypermetropia. There's also what is called blindness. Blindness can be divided into four types of blindness, which are night blindness, river blindness, blindness due to injury, and color blindness. So let's take a look at short sight, long sight, and then some forms of blindness. So we start with myopia. So this is an eye defect where an individual can clearly see close objects, but distant objects appear blurred. Okay, so you can see things that are closer to you, but things that are not close to you, they are not clear. So this is because rays from distant objects are brought into focus in front of the retina instead on the retina. It is caused by an abnormally long eyeball or a permanently thick lens. So if by birth or maybe as with time you develop an abnormally long eyeball or maybe a thick a lens which is permanently thick, then you're going to have myopia. So it can be corrected by using concave lenses. So there are two types of lenses. They are what are called concave and convex. Okay, so this defect can be corrected by using concave lenses. So you're going to an individual has to put on lenses which are of concave type. So let's take a look at how concave lenses can correct short sight. So this is the eyeball of an individual with myopia. So it is abnormally long. So when light comes from an image that is very far, remember myopia is short sight, which means you can see things that are closer to you. So if when rays come from an object that is very far, remember rays from an object that is very far are parallel. So when they come, they are focused here instead of on the retina. Because of this, the individual won't be able to view or to see the image clearly. Okay, so what can be done is we can just give them lenses of this type. Okay, so how do these lenses help? So if rays are coming, they are going to go in this path. So they are going to come here. Then from here, they are going to be diffracted a bit. Okay, like this. When they're diffracted like this, when they reach the lens, they are going to be diffracted again till they meet here instead of here. Okay, so that's what concave lens do to make sure that short sight is corrected. So concave lens, they make rays divert a bit. So they are coming in parallel, but when they reach here, they divert a bit. Okay, as if the rays are coming from an object that's near when it's far. Okay, so that's how myopia is corrected. So the next one is long sight, which is hypermetropia. So for hypermetropia, it's a defect where an individual can clearly see distant objects, but cause objects appear blurred. So objects that are very far can be seen, but objects that are near cannot be seen clearly. Okay, so it is caused by an abnormally short eyeball or a permanently thin lens. Rays from close objects are focused beyond the retina. Okay, so this can be corrected by using convex lenses. In myopia, we use concave, but here we're going to use convex lenses. Convex lenses are lenses that are thicker on the middle and thinner on the edges, like on top and on the bottom. So let's take a look at the eyeball of an individual with hypermetropia, and also how the convex lens looks and how it is used to correct hypermetropia. So this is the eyeball for an individual that has hypermetropia. So it is abnormally shorter than normal. So rays from a close object, remember, they divert, so they're going to come like this. So when they reach here, when they're refracted, they're going to meet somewhere beyond the retina. Okay, so because of this, images are not going to be focused on the retina. Okay, so don't forget, other than the eyeball, which is shorter than normal, the lens can also be permanently thin. So now we are going to introduce a convex lens. So the convex lens, what's going to do, this light, it's going to make it parallel as if it's coming from afar. Okay, so once this parallel light reaches here, it's going to be refracted in a normal way so that it is focused. So this is how this lens is used to correct hypermetropia. Next, look at blindness. So this is defined as lack or loss of visual perception. Okay, when an individual cannot see or cannot see clearly. So there are different forms of blindness, some of which are first, blindness due to injury. This is where someone is blind because of an injury. Okay, so this one is not caused by anything specific other than injury. Okay, then another type of blindness is night blindness. Okay, so this is a condition where vision becomes diminished in dim light. So when someone goes where there's no too much light, they can't see clearly. So that is night blindness. Okay, it is caused by a deficiency of vitamin A. Vitamin A is required by the eye to form a visual pigment called rhodopsin that is required for vision at low light intensities. Remember, people say we should be eating carrot for us to improve our vision. So this is the idea. Okay, we need vitamin A for us to avoid night blindness. Last, we look at river blindness. Okay, so river blindness is called river blindness because it is caused by a worm that is found in rivers. Okay, so it's a type of blindness caused by a worm called filario worm. Okay, so adult filario worms, what they do is they produce tiny larvae. So these tiny larvae are called microphyllary. Okay, microphyllary. Okay, so these microphyllary attack the eyes. When they attack the eyes, they can cause various conditions such as glaucoma, cataracts, and conjunctivitis. The end result is blindness. So here are some methods of preventing or treating river blindness. First, we can be spraying rivers with insecticides to kill the larval stage of the vector. We can also be applying dimethylphthalate to clothing or the skin in order to repel the vector for several hours. So this, when applied to your skin or clothing, the vector is going to keep away. We can also use dosages of diethylcarbamazine to kill the microphyllary. So this chemical kills the microphyllary. Okay. Also injections of a chemical called suramine, which ends up killing adult worms in the body. So if they get into your body, you just need an injection of suramine. Then this suramine is going to kill adult worms in the body. Also, you can make use of long clothing to prevent bites by the vector. Okay, so spraying rivers with insecticides, application of dimethylphthalate, dosages of diethylcarbamazine, and injection of suramine. Also, using of long clothing to prevent bites by the vector. The next is color blindness. So this is a situation where an individual cannot perceive certain colors. Okay, so maybe they can only perceive 3 colors. Okay, maybe blue, green, and red. They cannot perceive other colors. So that's what color blindness is. Sometimes it can be where certain color they perceive it as a different color. So this is just a blindness where an individual has can only perceive certain colors, not all the colors. Sense organs, we take a look at the eye, the ear. So this is a model representation of the ear. So the ear is basically made of 3 parts. There is the outer ear, which is this part made of the pinna, and also called the ear lobe, and the external auditory canal. Then the next part is the middle ear, which is made of these three bones here: the malleus, the incus, and the steps. Okay, and also this tube here called eustachian tube. Then there is the inner ear, which is made of the semicircular canal. These ones here, there are three. Okay, then it is also made of this part here, which is called the oval window. Okay, then there's also this part here called the round window, and also there's this called the cochlea. Okay, and auditory nerve. All right, so here on the semicircular canal we've got the ampulla and the utriculars. Okay, let's take a look. Anyway, let's discuss the parts, or just this grouping of the various parts before we can go into each of the parts. Then we'll also take a look at a realistic presentation of the human ears, so maybe you're going to be able to relate. So this is the sense organ that is responsible for detection of sound, as we know. So the outer ear or external ear is made of an air-filled cavity. It is an air-filled cavity made of the pinna and external auditory meters. Okay. Then the middle ear is made of the eardrum. I forgot to mention about the eardrum on the image, but it's made of the eardrum, also called tympanum, the ossicles, and the eustachian tube. The ossicles are those three bones: the malleus, the incus, and the steps. Okay. Then the last part is the inner ear or internal ear, which is made of the cochlea, the semicircular canals, the vestibules or vestibular apparatus. So this is a realistic presentation of the human ear. Of course, the pinna and the external auditory canal makes up the external ear. The job of the pinna is to trap sound and transmit this sound to the external auditory canal. This part here is called the external auditory canal. So the external auditory canal, its job is to collect sound from the pinna and transmit out this sound to the eardrum. This is where the external ear ends. So go to the middle ear. The middle ear is made of the eardrum or tympanium membrane. So the tympanium membrane or tympanic membrane or the eardrum, its job is, as the sound is coming, it's going to be vibrating depending on the type of sound it's receiving. So these vibrations are going to be transmitted to the ossicles, these three bones here. So these ossicles now, the first one is the malleus. As the eardrum is vibrating, it is also going to be vibrating in unison. In the process, it will be hammering the incus here. So as it is hammering the incus is going to collect this sound and sends it to the steps. Okay, the step is going to take it to this part here, which is called the oval window. Now we're not going to before we can continue with how the sound moves here, the other part of the inner ear, I mean of the middle ear, is this part here called the eustachian tube. Okay, so the eustachian tube, and of course this whole cavity in which the ossicles are suspended is called the tympanic cavity. Okay, so this tube here, eustachian tube, is connected to the pharynx. Okay, the pharynx somewhere near your neck. So it equalizes pressure between the external environment and the ear. If there's too much pressure from outside, the eardrum can burst. So its job is to make sure that the pressure outside and inside is equalized. Okay, so it's very important. Going back to how sound moves, when it reaches the oval window here, it goes to the inner ear, which is made of the cochlea, the semicircular canals, the vestibular apparatus. Okay, so this is where now sound is going to be taken to the brain, to the central nervous system. So if we go back to our diagram here, let's just visit each of the parts. We understand how they work and all the information about them, like the way I explained, but a bit in details for some of the most important parts. So the pinna, like I said, it collects sound waves and passes them on to the external. Sorry for that. It collects sound waves and passes them on to the external auditory canal. Okay. Then the external auditory canal carries sound waves from the pinna to the tympanum. It also produces wax to keep the eardrum supple and trap particles that enter the ear. Okay, so it protects dust particles, stony particles, soil particles from entering the ear by producing wax. It also contains hair to trap particles entering the ear. Then we go to the eardrum, the tympanum. So this is a membrane that vibrates when hit by sound waves in order to transmit sounds to the ossicles that are found in the middle ear. Now we go to the three bones, the ossicles. So these are a set of three small bones found in the middle ear, and their job is to transmit sounds from the eardrum to the oval window. And they also amplify sound. So if sound that is being received by the eardrum is very small, these ones are going to make it a bit louder. Okay. Go to the eustachian tube. This eustachian tube, what it does, like I said, it's a tube that connects the middle ear to the back of the pharynx, and its function is it equalizes pressure between the middle ear and the atmosphere. Okay, so when you are swallowing and yawning, it makes sure that pressure is equalized between the middle ear and the atmosphere. So this prevents the eardrum from bursting when atmospheric pressure changes drastically during an airplane flight or deep sea diving. Next is the oval window. Okay, so the oval window, remember, is the one that is connected to the steps. The steps is the last of those three bones. So this picks up vibrations from the steps and transmits them to the perilymph in the inner ear. So in the inner ear, there is a perilymph which receives these vibrations. Okay, on the bottom of the round window there is, of the oval window, there is a round window. Okay, so the job of the round window is to relieve pressure that builds up in the perilymph during vibrations of the oval window. So as the oval window is vibrating, there's pressure that is built in the perilymph. The round window has to equalize that. How it does that is, when the oval window moves inwards, the round window does the opposite. It moves outwards. When the oval window moves outwards, the round window moves inwards. So that's how it protects, that's how it relieves the pressure. Next, look at the vestibular apparatus. So this is made up of three parts: the sacculus, the utriculus, and the ampullae. Okay, and three semicircular canal. So it is made of these three parts: sacculus, utriculus, ampulla, and three semicircular canal. So the sacculus links the rest of the vestibule to the cochlea. Okay, then the utriculus contains receptors that are sensitive to gravity and body posture. So this utriculus makes sure that they know how your body is oriented. Okay, if you are doing somersaults, it will know that the body has turned upside down. Okay, so the semicircular canal are responsible for balance in the body during rotation movements of the head. So when you are dancing, you are moving your head, the body is balanced by the effort of the semicircular canals. Then the last one, the ampullae, are the swollen ends of the semicircular canal. Okay, so they help. So the ampullae help in controlling balance by generating impulses that inform the brain about the position of the body. So these ampullae are the ones that generate impulses, and then they inform the brain about the position of the body, and the brain will know what to do. Then we look at the cochlea. So this is a code structure that detects sound intensity and frequency and transduces sound to generate nerve impulses. So this is the one that does the actual job. Those sound waves, when they reach, it will detect the frequency of that sound and the intensity, how big that sound is, and then it will change that into nerve impulses so that they are taken to the brain, so that the brain knows the sound that has reached the ear. So nerve impulses from the ear are carried to the brain by the auditory nerve, just like the optic nerve in the eye. So defects of the ear, we're talking about deafness. So deafness is an ear disorder where hearing is impaired or diminished, where you cannot hear or you can't hear properly. You need something to be loud for you to hear. So causes of deafness include the following: overproduction of wax, which leads to blockage of the external auditory canal. So if your ear is producing too much wax such that the external auditory canal is blocked, then you can be deaf. Also exposure to loud sounds, which might damage the ear ossicles. Again, inserting hard and sharp objects into the ear, causing damage to the eardrum. And there's this one, which is different infections of the inner ear or the throat. So if the throat or inner ear is infected, you can end up having deafness. So how do we properly take care of our ears? Clean the ears regularly with soft materials to remove excess wax. You can avoid exposure to loud sounds. This can be done by covering the ears when exposed to loud sounds. You can also treat all infections of the inner ear and throat. So this marks the end of coordination. Happy hunting.